This video covers partial fraction decomposition. Decomposing a fraction or decomposing a rational expression means breaking it into two or more fractions that were added or subtracted to obtain that rational expression. Here's an example. So I am here to subtract two rational functions or rational expressions. To subtract two rational expressions, I need to have common denominator, which will be 2x plus 1 times x minus 3. And I'll have to multiply first fraction with 2x plus 1, numerator and denominator, to get equivalent fractions, and second fraction with x minus 3. Don't forget to distribute the negative sign. So it turns out to be 3x plus 5 divided by 2x plus 1 into x minus 3. Now we will be decomposing this rational expression that we obtained into two fractions that were subtracted to obtain this rational expression. Decomposing a fraction. So first case 1, is when denominator is product of linear factors, like in this case. So denominator is product of linear factors. The way we set it up is going to be equal to a over x minus 3 plus b over 2x plus 1. So each of the fractions get one of the linear factors. And if we have more, we keep on adding more variables in the numerator and adding that distinct linear factors in the denominator. Now, numerator does not do much when we are setting up a partial fraction. Denominator is the one that plays bigger role in setting up a partial fraction. So now the next step will be, my goal is to find a and b. So I'm going to go ahead and multiply both sides with the denominator x minus 3, 2x plus 1. You will have to use skills like plugging a special number to evaluate an algebraic, solve an equation, or solving system of equations. So make sure you review those. Solving linear equations and system of equations. So I'm going to be distributing this into all three fractions here. So on the left hand side, I would be left with 3x plus 5. Right hand side would be a times 2x plus 1 plus b times x minus 3. Now we can do clever substitution, or we can also distribute and combine the like terms and equate the coefficients. In this case, seems like clever substitution is easier, faster, so I'm going to do that. First time, I'm going to let x be equal to 3 because I know that's going to make this factor 0. I will be able to find a from there. Let x equals 3. So that leaves me with 3 times 3 plus 5 equals 8 times 2 times 3 is 6 plus 1 plus 0. So 9 plus 5 is 8 times 7. 14 equals 7a. It comes out to be 2. Okay, so we just found a as 2. Now the second time, I'm going to let x equals negative 1/2. And the reason why I'm choosing that number is that's going to make this factor 0, and I would be able to find the b here. So 3 times negative half plus 5 equals 8 times 0 plus b times negative half minus 3. So that's negative 3 halves plus 5 equals, let's combine the negative 1/2 minus 3. That would be negative 1 minus 6, which is negative 7 halves. On the left hand side, I would have 7 halves positive. 7 halves equals negative 7 halves b. We can divide both sides with negative 7 halves, and we can see b is going to equal negative 1. Now we're going to replace the a and b by what we just found. So 3x plus 5 over x minus 3 times 2x plus 1 is equal to, don't mix the positions of a and b. that would not give you the same fraction. So replace a by a is 2 over x minus 3, and b is negative 1 over 2x plus 1. So these were the two fractions that were subtracted to obtain this new fraction, and that process is called partial fraction decomposition. And we can verify that, yeah, that's correct. These are the two fractions we started with to get this new fraction. Right, another example, when denominator is a product of linear factors. So in this example, I'm going to go ahead and factor the denominator first. So we can factor the denominator by using AC method or bottoms up method, which are however you factor the trinomials. 8 times 3 is 24, negative 10. Two numbers that multiply to give me 24 and add up to give me negative 10 are 12 and 2. And we're going to divide them both with 8x and 8x. So that's going to leave me with 4x minus 1, 8 over. That would be, we can divide both with 2 actually. So if we divide both with the 2, 12 times negative 2 gives me, actually it would be not 12 and negative 2 because that wouldn't give me positive 24. Let's think about it again. It's going to be 6 and 4. So we want two numbers to multiply to positive 24, add up to negative 10. I thought of 12 and negative 2, but they will multiply to give us negative 24. So that would be not okay. We'll have to go with negative 6 and negative 4. These are the two numbers that multiply to give me positive 24 and add to give me negative 10. Divide both of them with 8x and 8x and simplifies to 2x minus 1. Doesn't matter which product you write first, multiplication is commutative. And if we simplify here, divide both with 2, 4x minus 3 is my other factor. Again, two linear factors, so I'm going to set them up. We can write any factor first, it does not really matter. A over 4x minus 3 plus b over 2x minus 1. Multiply both sides of this equation with the denominator, which is 2x minus 1 times 4x minus 3. Right, and that's going to leave us with only x in the left-hand side and a times 2x minus 1 plus b times 4x minus 3 when we distribute. Okay, now we can do clever substitution if that's easier, or I would like to show you another method, which is distributing and getting the like coefficients together or like terms together. So if you were to do that, that would be 2ax minus a plus 4bx minus 3b. Let's combine the coefficients of x here, which is going to be 2a plus 4b and minus a plus 3b. I pulled out factored a negative 1 out. All right, now let's equate the coefficients. Whatever is the number in front of x on the left-hand side, that's going to be number in front of the x here. And the constant term, we don't have any, that's going to equal a plus 3b. So 2a plus 4b is equal to 1, and a plus 3b is equal to 0. Let's go ahead and solve this system. I'm going to multiply the second equation with negative 1. Now I'm thinking I shouldn't have factored the negative at first place. Let's do with negative 2. Go back, and the second equation was a plus 3b equal to 0. So let's multiply the second equation with 2. Turns out to be the first equation remains the same. Second equation, if I multiply with the negative 2, gives me negative 2a minus 6b equal to 0. We can cancel this, and it turns out to be 4 minus 6 is negative 2b equal to 1. B equals negative 1/2. So we just found the b, which is negative 1/2. Now we can plug this b back in to either one of these equations, and we would be able to find a. So I'm going to plug it into the second one because it seems like it's a little bit easier to. A plus 3 times negative 1/2 equals 0. A minus 3/2 is 0. This gives me a equals 3/2. So we just found the a and b. Now we can see the partial fraction decomposition for this fraction is going to be, so we can say that this original fraction is going to equal a. A is going to be replaced by 3/2. 3/2 4x minus 3, and b is replaced by negative 1/2, negative 1/2, 2x minus 1. Okay, so these are two fractions that were added or subtracted to obtain this new fraction. Another example, when denominator has repeated linear factors. If we have repeated linear factors in the denominator, we have to set them up as a over first factor, x minus 1, plus b over x minus 1 squared, okay? Because we have x minus 1 squared here, we have to set it up this way, c over the remaining factor. Again, rest of the process remains similar. We're going to multiply entire equation both sides with the denominator, which is x minus 1 squared times x plus 2. So what we can do now is, let's go ahead and distribute this denominator into every single fraction of this equation, and on the left hand side the entire denominator will cancel. A times minus 1 squared. Clever substitution is not going to work here all the way because I won't be able to cancel each of the individual factors. Let's see, what would we do then? So we can let x be 1. If I choose x to be equal to 1, we will be able to find the b. If I choose x to be 1, we can find b. So let's see. 3 times 1. Let's go ahead and plug x as 1 on both sides. Each factor that contains x minus 1 is going to become 0. If I choose x to be 1, so it's going to be 0 plus b times 3 plus 0. So left hand side is 3 times 1 plus 1 is 4. So 4 equals 3b. b turns out to be 4/3. We just found one of the coefficients, which is b, and then we got b as 4/3. We can also do clever substitution to find, if I let x be negative 2, we can find c. Let x be negative 2, we should be able to find c. So our equation was 3x plus 1 equals a times if x is negative 2, these two factors will turn into 0. We just found c as negative 5/9, and we also found b. But there's no way we can find a by doing clever substitution. So now we'll have to use a different technique. We'll have to, we can pick any value of x and put it in on both sides of the equation to find the missing value. So in this equation, I'm going to choose any other value of x and plug it in. I'm going to go ahead and plug x as 0 since I know b now and I also know c now. I should be able to find a. So let x be equal to 0. It's going to be 3 times 0 plus 1 is going to be 1 equals a. A is what we're looking for, and we're replacing x by 0. Negative 1, negative 2 plus b is we just found it on the previous page, 4/3, and x is 0, we just chose, and c is -5/9. We just chose x to be 0. So the only missing piece in this case is an a. Only missing case in this case is a, so we will be able to find out a in here. -2a plus 8/3 minus 5/9, because -1 squared will be +1. So 1 equals -2a, and we can combine these fractions, make them same denominator. That's 24 minus 5, which is 19/9. 24 minus 5 is 19/9 plus 19/9. Let's go ahead and subtract from both sides, and 19/9 from both sides, -2a equals 1 minus 19/9, and that's going to leave us with -2a equals 1 minus 19/9. That's -2a equals -10/9, and we can go ahead and divide both sides with -2, and that's going to be a equals -10/2 times 9. When we simplify, this is going to be 5/9. So a comes out to be 5/9. Now we can go back and replace a, b, and c by what we just found. A is +5/9, c is -5/9, and b is what we found earlier. So 3x plus 1 over x minus 1 squared times x plus 2 is equal to, we said the fraction a is 5/9 over x minus 1, and b was 4/3 x minus 1 squared, and c is -5/9 x plus 2. So if you want to verify, you can go ahead and add or subtract the fractions on the right hand side. We would be able to get the fraction on the left hand side. Right, next example is when denominator has a quadratic, when fraction has a quadratic denominator. So if my denominator is a quadratic factor which is not factorable, we cannot break it any further. So to set up the partial fractions for this kind of fraction, we will use a linear factor in the numerator. In the numerator, we will use linear factor ax plus b, x squared plus x plus 1, plus c over x minus 2. Now we're going to multiply everything on both sides with the denominator x squared plus x plus 1 times x minus 2. Leave me with 5x in the left hand side, ax plus b times x minus 2 plus c times x squared plus x plus 1. Again, clever substitution is not going to work here. I can only find out the factor c, but we won't be able to find, if I choose x to be 2, we can find c, but we won't be able to find a and b by doing clever substitution. So I'll have to equate the coefficient by distributing. So let's go ahead and do that. 5x equals ax squared minus 2ax plus bx minus 2b plus cx squared plus cx plus c. Okay, now let's combine all the terms with x squared. That would be x squared times a plus c, and all the terms with x and the constant terms, plus x times -2a plus b plus c, and the constant terms are -2b plus c, equal to 5x. So we're going to equate the coefficients now, the numbers in front of. Actually, we could go ahead and find the c really quick. That would make my life easier. So let's stick with this for now. So we have 5 equal to a plus c, and 0 equals -2a plus b plus c, and 0 equals negative 2b plus c, because the term with the, actually a plus c is going to be 0, because the term with x squared is 0 on the left hand side. A plus c is 0, negative 2a plus b plus c is 5, and negative 2b plus c is 0. Now to solve this system, it's probably easier to, at this step, we could have let x to be equal to 2. At least that would help me find c. So left hand side is 10, and the right hand side would be 0 plus c times 4 plus 2 is 6, 7. So it turns out to be 10 is equal to 7c. C is 10 divided by 7. So at least we found the c, and now we can plug that c in here to find a. A plus c is 0. This gives me a should be equal to a plus 10 over 7 is 0, which gives me a is equal to negative 10 over 7. So we just found the a, we found the c, and now we're looking for b, which we can plug in the third equation that we have. Negative 2b plus 10 over c is 0. Gives me negative 2b is negative 10 over c, 10 over 7. B is equal to negative 10 over negative 2 times 7, which is going to be positive 5 over 7. So we just found the a, b, and c, and we can plug them back into the original equation and figure out what our partial fraction is equal to. Let's see if a is negative 10 over 7, negative 10 over 7x plus b is 5 over 7 divided by x squared plus x plus 1 plus c is 10 over 7 over x minus 2. We can simplify it a little bit and can pull out a negative 2 from here. So that can be written as negative 2 times, actually we can pull out negative 5. Negative 5 times 2x plus 1 over 7 times x squared plus x plus 1 plus 10 over 7 times x minus 2. So these are the two fractions that were added or subtracted to obtain this fraction. Another example with quadratic factors, and I'm gonna go through it a little bit faster. We will first have to factor the denominator, which turns out to be the factors for denominator in this case would be 3x squared minus 2x plus 8. We can factor it by grouping, and it would be x squared plus 2 times x minus 1. Pull out a common factor between the first two terms, and then the common factor between the last two terms. Now again, we have a quadratic factor here, which is not factorable anymore. So we are going to set it up as ax plus b over x squared plus 2 plus c over x minus 1. Multiply both sides with the denominator, which is x squared plus 2 times x minus 1. And that's going to leave us with 3x squared minus 2x plus 8 equals ax plus b times x minus 1 plus c times x squared plus 2. All right, we can do clever substitution here. So if I let x be equal to 1, I'm able to find the c, which is 3 minus 2, 1 plus 8, 9, equals, this term will be 0, c times 3. So this gives me c is equal to 3. We just found the c here. Now I'm going to go ahead and equate the coefficients and figure out the remaining terms. So 3x squared minus 2x plus 8 turns out to be I'm gonna go through it a little faster. Negative a plus b, just equating, distributing and combining the like terms, getting all the x terms together, all the x squared terms together, and constant terms together. Now we can see that here a plus c has to equal 3. And we already know what c is. That means if I plug c as 3, then a is going to equal 0. So we just found the a, and we already know the c. The only mystery piece is the b, which we can use from the second piece here. Oh, that was negative a plus b into x. Negative a plus b is a term with x that has to equal negative 2. So instead of a, I'm going to add 0. B will turn out to be negative 2. So we found the a, we found the b, and we already found the c. We can replace them in here, and that would be our partial fraction decomposition. So this fraction is going to equal negative 2 over x squared plus 2 plus 3 over x minus 1. Now we're going to discuss the last case when we have an improper fraction. If we have an improper fraction for partial fraction decomposition, we need to do long division first. So long division here, x cubed plus 2x squared minus x plus 1 divided by x squared plus 3x minus 4. X squared times what gives you x to the third? It would be x. So that's x to the third plus 3x squared minus 4x. Subtract, that would change the signs, negative x squared plus 3x plus 1, and x squared times 1, so which is negative x squared, negative 3x, and plus 4. Add, change the signs so that the denominator is 6x minus 3. So we can write this this fraction, x to the third plus 2x squared minus x plus 1 over x squared plus 3x minus 4 as x minus 1 plus 6x minus 3 over x squared plus 3x minus 4. Now we're going to break this piece using partial fraction decomposition, and we'll be able to figure out what fractions were added or subtracted to obtain this new fraction. So let's work on 6x minus 3 over x squared plus 3x minus 4. Let's factor it. That would be x plus 4, x minus 1. And when we set it up, these are the linear factors, b over x minus 1. Multiplying with the LCD, x plus 4, x minus 1, leaves me with 6x minus 3 equals a times x minus 1 plus b times x plus 4. We can do clever substitution here to find out a and b. So let x be 1. That would give me 3 equals 5b. So b is 3/5. And we can let x be negative 4, which is negative 24 minus 3 is negative 27, equal to a times negative 5. A is equal to 27 over 5. Right, so we do have our fraction decomposed. So we can write it as the fraction we started with. We can plug the a and b in here. So this is going to equal x minus 1 remains. And instead of b, a plug in 27 over 5. 27 over 5 times x plus 4. And b is 3/5 plus 3/5 times x minus 1. That is all about partial fraction decomposition. So we decomposed our fraction. If you want, you can add a 1 underneath here or not. And we just decomposed our fraction into its pieces that were used to add or subtract, that were added or subtracted to obtain this new fraction. I hope this helped.